But I can actually show you guys how you can find that corresponding function just by looking at the code. So we know that this is our main function, and we can see that some variables are being set from the start. So in our main, we can see that 0x0 is being placed, 0x0 is being placed into 0x3 RBP, and 0x3 is being placed into 0x8 RBP. So some variables are getting set to 0x3 and 0x0. So let's say our x integer is equal to 0, and then int y is equal to 3. And then when we call our function, notice that we're using the values in EDI and ESI to place them into different places in the stack, like making a copy of the values in EDI and ESI. Well, if we look in our main function, notice that we placed the values of 0xe and 0x8 into EDX and EAX, which eventually got moved into ESI and EDI, which, look over here, we're using in our recursive function. So we can say that our recursive function is taking in x and y as parameters. So when we call the recursive function, we're passing x and y, and then we can even go to our recursive function here and see that it's looking for these parameters, x and y. Okay, and also you can see that those x and y values, that x is being placed in 0x4 RBP and y is being placed in 0x8 RBP. So let's make sure to make this clear for you guys. Minus 0x4 RBP and then minus 0x8 RBP. This is like our x and this is our y. Okay, and then over here we're moving x into EAX, and then we're going to compare our x, we're going to compare y and EAX, which has x. So we're basically comparing x and y. And what are we comparing? We're comparing if they're equal. And if they're equal, then we would jump to 517f and we would go down all the way over here, and that would basically end our recursive function. So basically our base case is if x and y are equal. So we know that if x equals y, we would return x, because we would move RBP, or we would move x into EAX, which is our return value, and then when we do leave in red, it would return x. Otherwise, if we look at this, we can see that if it's not equal, then we would actually go down to 6.8 instead. We would go to this instruction over here, and we're going to move our x into EAX, and then we're going to add 1 to x and place it into EDX. So EDX is basically 1 plus x. And then we're going to move y into EAX. This becomes y. And then we're going to move EAX into ESI. And then we're moving EDX into EDI. Equals 1 plus x. And then we're calling 0x5149, but this time with our updated values with our new EDI and ESI. So now we're actually calling our recursive function with x plus 1 and y. So otherwise, we would return recursive x plus 1 y. This is really important. Notice how we're updating these. But another thing to note is later, we're also, before we leave this function, we're going to move our x into EDX, and we're going to add it to this return value. So we're not just returning the recursive call, we're also going to return EDX plus that recursive call, which has x. So we're going to return x plus our recursive call. So that's what our recursive function would look like over here. And then in our main function, we're calling 0x5149. So then for the remaining main function, what we're doing is we're actually storing recursive into, we're going to return that resulting value into our variable. Let's just call it int result equals that recursive call. And then later, we're going to move that RAX into RDI, and then we're going to print it. So we're going to print result. And then we're moving 0 into a return value, and then we're going to return that EAX value, which is 0, so we're going to return 0. So just by looking at the assembly and kind of like seeing where things are moving between the registers, you can actually figure out what the code is supposed to look like. So this is our main function, and then this is our recursive function. Thank you for watching, and I hope that helps you guys understand a little bit more about what recursive functions will look like and how that stack manipulation works with the assembly instructions.